Hi to everyone. MEM School of Engineering, Department of Electrical and Electronics Engineering, online classes, subject Digital Logic Circuits, unit number 4. So this is the course objective and outcome of this Digital Logic Circuit. This is syllabus, textbooks and reference, and unit 4. So last chapter we discussed about unit number 3 with synchronous sequential circuits. That means all the flip-flops, that is all the memory elements are connected with the common clock pulses, so it is called as synchronous. So in that we discussed about counter, shift register, like that we done. So now we are going to see about the unit number 4, asynchronous sequential circuit and programmable logic devices. So asynchronous and sequential logic devices, that is one of the fastest sequential circuits. It is having some errors and hazards, like that we are going to discuss in this chapter in the first half. Second half we are going to discuss about PLD, that is programmable logic array, programmable array logic, and CPLD and FPGA, like that we are going to discuss. First, the sequential circuits is specified by the time sequence of inputs, output, and internal states. In synchronous sequential circuit, the output changes whenever a clock pulse is applied. The memory elements are clocked flip-flops. So asynchronous sequential circuits do not use clock pulses. The memory elements in asynchronous sequential circuits are either unclocked flip-flops or time delay elements. So these are the difference between a synchronous sequential circuit and asynchronous sequential circuit. In synchronous sequential circuit, memory elements are clocked flip-flops. In asynchronous, memory elements are either unclocked flip-flop or time delay elements. The change in the input signal can affect memory element upon activate of clock signal. The change in the input signal can affect the memory element at any instant of time. So in synchronous sequential circuit, the maximum operating speed of clock depend on time delays involved. Therefore, synchronous circuit can operate slower than asynchronous. In asynchronous circuit, because of the absence of clock, it can operate faster than synchronous circuit because state of changes variation. Sometimes it will be changed in the one state or other state. But in the synchronous, every time you have to define the four state. Okay, so asynchronous circuits will faster than the synchronous. Synchronous circuit easier to design. Asynchronous circuit more difficult to design. This is the difference between these synchronous and asynchronous sequential circuits. This is the basic block diagram of asynchronous sequential circuit with the delay component. So delay component called as a D flip flop or other flip flops they are used. So according to input variables to be considered, the asynchronous sequential circuit can be uh, divided into two types. That is a fundamental mode circuit. Another one is pulse mode circuit. So fundamental mode circuit assumes that the input variables change only when the circuit is stable. Only one input variable can change at a given time. Inputs are level 0 or 1 and not pulses. Okay, inputs are 0 or 1. That is a level they are defining. Okay. So pulse mode circuit assume that the input variables are pulses instead of levels. Here they are using the pulse. For example, they are using spike for converting a one state to another state. The width of the pulses is long enough for the circuit to respond to the input. The pulse width must not be so long, that is, it is still present after the new state is reached. So these are the analysis procedure. If you want to design a asynchronous sequential circuit, we need a steps to involve. So first step is determine all feedback loops in the circuit. Second one is designate the output of each feedback loop with variable y1 and its corresponding inputs y1, y2 and yk. So k is the number of feedback loop in the circuit. So derive the Boolean functions of all y's as a function of the external input and the y's. So plot each y function in a map using y variables for the rows and the external inputs for the columns. So combine all the maps into one table showing the value of y is equal to y1, y2 up to yk inside the each square. Circle all stable states where y is equal to small y. The resulting map is the transition table. You have to define the transition table as well as the output state. So it is a simple problem to define the asynchronous sequential circuit. And asynchronous sequential circuit as is described as the following excitation and the output. So y is equal to excitation, that is x1 x2 plus y into x1 plus x2. Then z is equal to y. So these are the steps. First step is draw the logic diagram of the circuit. Second one, derive the transition table and flow table and output map. Then describe the behavior of the circuit. So this is the logic diagram of given equation. Then this is the truth table for given equation. Here they give the output, previous output y as a 0 0 0 0 or 1 1, like that they give. So here we are first we calculate the x1 and x2, then we are calculating the x1 plus x2 into y, then you will get the y value. So in the next state output z will be previous state output same. So z is equal to y, so it is easier one. But in the next conditions, it will be a they will ask y dash y1 plus 5, sorry y1 plus x dash, like that they will ask. So you have to find out the z value. So in this case, the y and z will be same. So there is no problem in the output, previous output and the next output. Next, you have to draw the transition table. So transition table define the which is used to define the stable and unstable state. So what is unstable state? Okay, first in this diagram, so in this diagram, it is the present state on the we have 0 0 0. So output state will be 0 0 0. But this one, this condition will changes the state from 0 to 1. So this is called unstable state. Same as here input is 1 1 1. So here these values are 1 1 1. But this state will be changed to 0. This is the unstable state that is represented in the condition. So but these two are called as a unstable state, remaining a stable state. Okay, you can put a dash on the unstable state. Then calculate the uh, k map, which is using the flow table, that is assign of a is equal to 0 and b is equal to 1. So we can call it as a behavior of the circuit. The circuit gives carry output of the full adder circuit. Okay, the circuit produce the carry output. So what is the carry output, like that? We can use the k map. I think you understand. For this, you can draw the K map. If you want to draw the K map means you have to put two pairs, this one and this two. So you will get the value. Z is equal to, so first one common value will be Y. This the here common value will be x2. So you will get y x2 plus. So this one also having y. So this common value will be x1. Okay, you take common y value. So y is equal to x1 plus and x2. Okay. So this is a format of carry full adder, that is A, B and B C like that. It is having, so it is produce the carry order output. That is a carry output of the full adder circuit. Okay, thank you.